Anthropic recently made a massive deletion to their AI system.
Yeah, a really massive one.
They removed over 80% of their own system prompt.
Right.
This was for their internal Claude Code tool.
Mm-hmm.
And the result was no measurable drop in performance at all.
None.
2-sec silence. Less really is more.
It absolutely is.
Let us unpack this.
Let us do it.
Welcome to the Deep Dive.
Thanks for joining us.
Today, we're exploring a massive shift in artificial intelligence.
A total paradigm shift, really.
You're moving past the era of prompt engineering entirely.
Right. You no longer need hyper-detailed rules to keep AI on track.
We are officially entering the era of context engineering.
Yes, and it is all about how you organize your sources.
It changes everything about our daily workflows.
It really does. And we're focusing on a very specific new generation today.
We mean models like Claude Sonnet 5 and Opus 5.
Exactly. This also includes Claude Fable 5 and the Sol model.
These newer models require a completely different approach from us.
Yeah, the old playbook just does not work for them anymore.
I find this transition incredibly fascinating to watch unfold.
It is wild to see.
Older models absolutely needed strict limits to avoid basic mistakes.
Yeah. You had to provide detailed rules for every single edge case.
Right. If you did not, the model would easily wander off track.
They needed those guardrails because they lacked true contextual awareness.
Yes.
They just could not make reliable decisions on their own yet.
But things have changed entirely with Opus 5 and Fable 5.
Oh, completely. Adding more instructions can actually make the results much worse now.
Really?
Yeah. When you over-constrain these new models, you degrade their overall performance.
I still wrestle with prompt drift myself, to be honest.
Yeah, we all do.
It is so tempting to just add one more specific rule.
Right. You see an error and you immediately write a new constraint.
Exactly.
Yeah.
Beat. But it is like programming a very rigid, inflexible robot.
That is a great way to put it.
You spend all your time micromanaging every single tiny movement.
That is the perfect way to describe the old mindset.
Mm-hmm.
The new way is like onboarding a really smart colleague.
You want someone who can just naturally read the room.
Yes. You give them access to the workspace and let them work.
Let us look at a specific example, like writing code comments.
Good idea. Older setups had strict rules for comment length or doc strings.
You essentially had to drive the car for the AI.
Right. You would specify exact word counts for every single function description.
You had to explicitly tell the AI exactly what to do.
Now, the instruction simply asks Claude to follow the code base.
It looks at the existing comment density and naming style.
Exactly. It also matches the coding patterns already used in the project.
So it uses its own judgment based on the surrounding environment.
Right. A fixed rule might be great for one single repository.
But it could be terrible for another completely different project.
Exactly. One project might be a sprawling legacy enterprise application.
Mm-hmm.
That massive project might actually need heavy, detailed documentation.
Right. Another project might be a sleek microservice with clean code.
Yeah, and that microservice probably prefers very few comments to stay readable.
Yes, and a rigid rule becomes unnecessary baggage in that situation.
Claude gets instructions from several overlapping sources at once now.
It looks at the global system prompt and the local files.
Right, and it looks at specialized skills and the current user request.
Every single instruction might make perfect sense in isolation.
Sure.
But when those sources conflict, the AI faces a real dilemma.
It has to decide which rule actually matters the most.
It burns valuable compute cycles just trying to resolve internal conflicts.
That is exactly why Anthropic deleted 80% of their prompt.
They realized Claude Code had become way too overconstrained.
Yeah, the model was spending too much time navigating contradictory rules.
And they saw zero loss in coding evaluations after the massive deletion.
None at all. Good context should only explain the ultimate goal clearly.
It should keep the mandatory limits that truly matter for safety.
Right. It should give Claude enough structural information to make the right decision.
2-sec silence. I hear what you're saying about deleting these rules,
Mm-hmm.
but my immediate fear is the risk of wild hallucinations.
Sure, that makes sense.
If we strip away 80% of the rules, what stops the model from hallucinating?
Well, it relies heavily on the surrounding context of the actual project.
Okay.
It makes reasonable decisions based on the existing patterns it sees.
Right.
Think about a developer joining your team for the first time.
Yeah.
They do not read a massive rule book on how to type.
No, they look at previous pull requests to see your established style.
Exactly. Claude does the exact same thing with its massive context window.
So it reads the room instead of reading a rule book.
Precisely. You only keep strict instructions for areas with real danger.
Things like security protocols, sensitive data, and strict production access.
Right. Everything else should be inferred from the actual working environment.
This brings up a really interesting philosophical problem for us.
How so?
Since we are stripping away the old rule book completely,
Mm-hmm.
how do we actually set boundaries without micromanaging the AI model?
Ah, that is the big question.
If we cannot use strict rules, what comes next?
We have to build much better interfaces for the AI.
Interfaces.
Yeah. People used to give Claude dozens of examples to follow.
They thought examples would help the model understand unusual data formats.
Right. But examples often create a very dangerous trap for the AI.
When you give Claude 5 examples of a specific format,
Yeah.
you unintentionally teach it that the correct answer must match perfectly.
Exactly. It mimics the syntax rather than understanding the actual boundaries.
It just copies the shape of the data provided.
Yes, it completely ignores the underlying logic of the request.
So a well-designed interface provides clear boundaries without limiting the overall approach.
Right. Phil Schmidt recently shared a great WebMCP shopping action example online.
Oh, I saw that.
It perfectly exposes a shopping action through a structured input schema.
Because an input schema acts as a strict blueprint for data.
Right.
Just to clarify, an input schema is a blueprint showing the exact data format a computer expects.
Exactly. The computer knows the exact format it needs to function properly.
You do not need examples when the blueprint is perfectly clear.
That is right. Instead of showing the agent several sample shopping requests, it is structured.
The interface simply defines the exact information it needs to work.
Yeah. For the add to cart function, it uses a simple name and description.
The schema requires just a string for the product ID variable. It also requires an integer for quantity with a minimum of 1.
Think about why that minimum quantity rule is so incredibly important.
Right.
If you rely on examples, the AI might accidentally suggest 0.
And trying to add 0 items to a cart completely breaks the system.
Exactly. The schema actively prevents that mistake from ever happening natively.
Claude understands the action perfectly from the name and description alone.
The schema simply explains which specific values are safely accepted.
It clearly outlines which fields are absolutely required to function correctly.
Yeah. There is a great 5-question checklist for when Claude fails.
Let us go through that. First, does the function name clearly describe the action being taken?
Right. Second, does each parameter clearly explain what value it expects?
Third, are required fields and accepted values properly defined in code?
Fourth, does the schema actively prevent invalid inputs from passing through?
And fifth, does the error message explain how to fix it?
If you follow that checklist, you will not need endless examples anymore.
You keep those instructions directly inside the function definition itself.
The boundary is enforced by the actual code, not the prompt.
Repeating guidance in the system prompt just adds more maintenance overhead.
It does not actually make the interface any clearer for the AI.
Let me push back on this idea for just a second.
Sure.
Are you saying we should never use examples again?
Well, examples are totally fine for really unusual or strange edge cases.
Okay.
Sometimes a legacy system requires a bizarre, non-standard date format. In those rare cases, a quick example saves a lot of time.
But they should not replace clear and well-defined interface definitions entirely.
Exactly. The boundaries should always come from the interface, not the examples.
Use examples for weird edge cases, not basic guardrails.
You got it. Strict rules usually come from one single mistake Claude made once.
A developer sees an error, panics, and adds a permanent rule.
They overreact and add a constraint for every future interaction.
That just builds up unnecessary limits for completely unrelated tasks later.
Precisely.
Interfaces handle specific actions perfectly in an isolated controlled environment. But what about massive multi-step workflows, like testing and deployment pipelines?
That is a whole different beast.
You certainly cannot just schema your way out of that complex problem.
You absolutely cannot. You need a way to organize massive amounts of procedural data.
If you load everything at once, the AI gets completely overwhelmed.
It loses track of the immediate task in a sea of instructions.
So we need progressive disclosure, meaning showing information only when it is actually needed for a task.
Exactly. We can hide the complex deployment rules until the end.
Claude does not need deployment rules when it's just writing tests.
Right. You want to keep the initial context very light and focused.
The initial context just shows where the detailed guidance actually lives.
You point the model to a main file like skill.md.
That master file then links to smaller reference files as needed.
Yeah, it only loads them when that specific stage of the workflow hits.
During the testing phase, it only reads the testing guidelines.
Claude still knows that deployment verification is required eventually later on.
But the detailed guidance enters the context only when it is useful.
This helps us solve one of the biggest problems in context engineering.
Which is?
You must remove outdated and repeated instructions from your context entirely.
Yeah. Context often grows wildly because the same rule appears absolutely everywhere. You find the same coding standard in the main system prompt.
Right.
Then you find it again in the local CLAUDE.md file.
Yeah.
And it pops up again in the specialized skill files.
When one copy changes, the other versions remain totally outdated immediately.
You have to avoid duplicate instructions across your global and local files.
Repeating the same rule just adds expensive tokens to every single session.
He does this without giving Claude any new information at all.
There was a fascinating example from Matt Van Horn on X recently.
Oh, I read about that.
He completely decluttered his own AI workspace setup just last week.
He noticed irrelevant info was bloating every single session unnecessarily.
Yeah, he reduced his entire memory setup down to just 6 files.
6 files.
Whoa! Imagine scaling to 1 billion queries with just 6 memory files doing the heavy lifting.
That is insane efficiency.
It is a completely different way of thinking about AI memory architecture.
Most developers have dozens of messy files cluttering up their workspace.
Right. It really forces you to keep only the absolute clearest version.
Move deeper guidance into a specific skill or reference file instead.
Keep auto memory reserved for useful information that crosses over multiple sessions.
But let us explore a hypothetical worst-case scenario for a moment.
Okay.
What happens when an outdated rule in memory conflicts with a new skill?
Claude basically has to guess which rule is the correct one.
That guessing game heavily degrades the model's overall reasoning performance.
It burns compute cycles just trying to resolve the internal logical conflict.
It might choose the outdated memory instead of the new skill.
Exactly.
Conflicting rules force the AI to guess, which kills accuracy. Sponsor. So we have deleted the clutter and stopped repeating ourselves entirely. We have embraced progressive disclosure to keep the initial context extremely light.
Right.
Where do the surviving instructions actually live in this new system?
Let us stack the Lego blocks of data right now to explain it.
Okay.
Anthropic recommends 4 distinct homes for your contextual information moving forward.
Think of this as building a very stable, structured foundation.
The first home is the system prompt itself.
Think of this as the green Lego base plate holding everything together.
Perfect analogy. This is exclusively for product-wide behavior and absolute general limits.
You want to keep all of your mandatory constraints right here.
This includes unbreakable rules for security, sensitive data, and production access.
It also includes strict restrictions on editing protected core system files.
Right. If a rule keeps the system safe, it lives on the base plate.
Task-specific instructions should never be in the system prompt at all.
Never. The second home is the CLAUDE.md file in your repository.
These are the foundational Lego bricks that build the basic walls.
This file should briefly explain what the repository actually does overall.
It is for lightweight, non-obvious repository gotchas and weird internal details.
It explains the cultural quirks of your specific development team.
For example, stating that shared types must stay in one specific file.
Or explaining that certain legacy files should never be edited by AI.
But here's the golden rule for this specific foundation layer.
Do not repeat things Claude can clearly see in the code itself.
Keep this file lightweight and focused only on the hidden, invisible rules.
Exactly. The third home involves specialized workflows known as skills.
Think of these as the specialized custom Lego pieces for specific actions.
These are complex standards that are specific to your team or product.
You might create separate skills for code review or production verification.
You could have entirely different skills for security checks or software releases.
Claude will load these skill files only when they are actively needed.
Right. If a skill becomes too long, keep skill.md as a guide.
Then move the highly detailed instructions into smaller supporting text files.
Exactly. The fourth and final home is the references section of the architecture.
Think of this as the instruction manual showing the final Lego model.
This is task-specific data that never becomes permanent context for the AI.
You give Claude existing code to follow for the current active task.
You provide test suites that clearly define the expected software behavior.
You can even provide HTML mockups that show the required design structure.
Specifications and quality rubrics also go directly into this temporary reference layer.
Anthropic heavily recommends using real code when possible for these references.
It gives Claude clear, high-fidelity structural instructions to work against directly.
A rubric can also show Claude what a genuinely strong result looks like.
Right, and verifier agents can then use that exact same criteria for final review.
It creates a perfect loop of creation and automated quality verification.
It really does.
Let us pause and think about the design aspects for a second.
Okay.
Why use an HTML mockup as a reference instead of just describing the design?
Because human language is incredibly imprecise when describing visual layouts.
Saying make the button pop means absolutely nothing to a machine?
Exactly. HTML provides high-fidelity structural instructions that AI models understand natively.
It is much more accurate than a screenshot or a written text description.
It leaves far less room for creative misinterpretation by the AI model.
Code speaks louder than words for an AI.
It really does. And the best part is you can implement this structure today.
You can actually prompt Claude to reorganize your current messy setup entirely.
Yeah, you do not have to sort through all of your files manually.
You can just use a simple /doctor command in Claude code.
It will identify duplicates and preserve all your vital security rules automatically.
It will review the existing files and remove unnecessary overlapping instructions.
It literally sorts everything into this nice 4-layer Lego cake for you.
It acts as an automated janitor for your messy context window.
Right. It identifies instructions that are duplicated, outdated, or logically conflicting.
It finds things that are already perfectly clear from the code base itself.
Then it moves each instruction to the exact right context layer automatically.
Mandatory safeguards stay securely anchored in the main system prompt.
Specialized workflows move cleanly into the modular skills section for later use.
As a project grows, its context always collects repeated, outdated instructions.
This is just the natural entropy of software development over time.
Before adding another rule, you should review your entire setup carefully.
Compare your system prompt, skills, and CLAUDE.md files regularly.
Remove rules Claude can already understand from the existing code structure alone.
Keep the workspace clean, and the model will perform significantly better.
2-sec silence. Let us take a moment to summarize this overarching philosophy.
It is so important.
Context engineering for Claude 5 models is fundamentally an exercise in restraint.
Right. We have to fight the urge to control every single variable.
Every single instruction needs a clear purpose and a very clear place.
Check what Claude can infer before adding a single new rule anywhere.
If the code already explains it, delete the rule from your prompt.
A simpler setup gives the model room to actually use its judgment.
It reduces logical conflicts and keeps the context window much lighter overall.
It allows the AI to breathe and analyze the actual problem presented.
It is about finally trusting the model to do what it was trained to do.
We do not need to hold its hand every single step of the way anymore.
We just need to give it a clean, well-lit room to work inside. Here's a final provocative thought to leave you with today. These new models are designed to adapt to your existing engineering culture.
They perfectly match the density and style of your current code base.
They essentially hold a digital mirror up to your own daily work.
Yeah.
So if these new models naturally adapt to the existing culture,
Right.
what does your messy, undocumented code say about you to the AI?
Oh.
Are we finally being forced to be much better writers overall?
Just so the AI does not learn all of our bad habits. It is a terrifying but absolutely necessary mirror for all of us today.
It forces us to elevate our own standards before asking for help.
It really does.
Open up your own Claude setup later today if you possibly can.
Right out.
See if you can safely delete 80% of your system prompt.
Trust the model to read the room and watch how it performs.
Thanks for exploring this deep dive with us today.
Keep your context light.
And your curiosity deep. Out Tiro music.